Cron Jobs. Cron Jobs are programs or scripts which users can schedule to run at specific times or intervals. Cron Jobs run with the security level of the user who owns them. By default, cron jobs are run using the /bin/sh shell with limited environment variables. Cron table files, cron tabs, store the configuration for cron jobs. User cron tabs are usually located in /var/spool/cron or /var/spool/cron/cron tabs. The system-wide cron tab is located at /etc/cron tab. File permissions. Misconfiguration of file permissions associated with cron jobs can lead to easy privilege escalation. If we can write to a program or script which gets run as part of a cron job, we can replace it with our own code. Let's run the Linux Smart Enumeration script with the level set to 1. In the results, we can see there are a number of cron jobs configured in the /etc/crontab file. Let's view the entire contents of that file. Both these cron jobs run every minute as root. Let's see if we can find the location of this overwrite.sh file. Now let's check the permissions on this file. The file is world writable. Let's edit the file and add a reverse shell which connects back to our local machine on port 53. Finally, all we need to do is switch over to our local machine, set up a netcat listener on port 53, and wait for the cron job to execute. The reverse shell is running as root. The path environment variable. The crontab path environment variable is by default set to /user/bin and /bin. The path variable can be overwritten in the crontab file. If a cron job program or script does not use an absolute path, and one of the path directories is writable by our user, we may be able to create a program or script with the same name as the cron job. Let's run the Linux Smart Enumeration script with the level set to 1. In the results, we can see that our user can write to a path that is present in a cron job, specifically the /home/user path. Let's view the contents of the /etc/crontab again. The path variable here shows that the /home/user directory is searched before any other, and this cron job specifies a non-absolute path for the overwrite.sh file. This means we can simply create the overwrite.sh file in the /home/user directory, and the cron job should execute that file instead of the original. Let's create that overwrite.sh file. We'll have it create an SUID version of bash for us in the /temp directory. Make sure the overwrite.sh file is executable, and we'll wait for the cron job to execute. We see that the root bash file has been created. It is owned by root, and it has the SUID bit set. We should gain a root shell when we run this file. Wildcards. When a wildcard character, usually an asterisk, is provided to a command as part of an argument, the shell will first perform file name expansion, also known as globbing, on the wildcard. This process replaces the wildcard with a space-separated list of the file and directory names in the current directory. An easy way to see this in action is to run the following command from your home directory: echo space asterisk. Since file systems in Linux are generally very permissive with file names, and file name expansion happens before the command is executed, it is possible to pass command line options, e.g. -h or --help, to commands by creating files with these names. The following commands show how this works. File names are not simply restricted to simple options like -h or --help. In fact, we can create file names that match complex options like the one shown. GTFO bins, which is accessed at the URL shown, can help determine whether a command has command line options, which will be useful for our purposes. Let's view the contents of the /etc/cron tab file again. The cron job we haven't looked at yet is this one, which executes the compress.sh script. Let's view the contents of this script. The script changes into our home directory, then executes the tar command with several options, including a wildcard character. If we use the GTFObins website, we can see that there is a way to spawn a shell with tar using command line options. We can modify this to our needs and spawn a reverse root shell back to our local machine. First, on our local machine, I'm going to generate a reverse shell Linux binary using MSF Venom. Back on the Debian VM, I've transferred the reverse shell binary to my home directory and made it executable. Now let's create two other files in our home directory, which will become command line arguments for the tar command when the wildcard is expanded. The first creates a checkpoint for every file that is processed. The second defines an action to run at every checkpoint. In this case, we want to execute our file. Finally, back on our local machine, I will set up a netcat listener and wait for the cron job to run. As expected, we get a reverse shell running as the root user.